All right, folks, so this video goes with lesson 2 of the AP Chem summer assignment. I am going to walk through some examples as just like last week. There is a notes handout also attached on Classroom, so you can fill that out as you go along. And just like last week as well, if you already know how to do the summer assignment without this video or the handout, you are welcome to do it without that. So the first thing in this lesson is something called percent composition. For percent composition, we're going to use this formula. The molar mass of the element in the compound. So whatever compound we're talking about, you take the molar mass of just one element over the molar mass of the entire compound. Then you multiply by 100 for the percent. The important thing here is that you remember that you multiply by the number of moles, which is going to be the subscript in that compound. So when I say the molar mass of the element in the compound, I'm meaning that you would multiply by the subscript as well. Another important thing to note is that percent by mass and percent composition are the same thing. So usually you'll see percent by mass when we're just talking about one element, but if it said like find the percent composition of this compound, which is sodium bicarbonate, it would mean that you would find it for each one of the elements. So we're just going to do this for oxygen right now because that's what this question's asking for. But if we needed to find it for each element, you would just do the same thing over again with each of the elements. So percent by mass of oxygen, which can be written this way, is the molar mass of the element over the molar mass of the compound times 100. So for oxygen, it's going to be 16, because that's the molar mass of oxygen from the periodic table. And then we're going to multiply by the subscript of oxygen. So here it's 3. And then the bottom is the molar mass of the whole compound. And we did this last week. So what I would do is take the molar mass of this entire compound, all of sodium bicarbonate, which is 84. And if you need a refresher on how to do that, please go back to the video and the notes from last week. So then when you do this out, you get 57.1% oxygen. So again, if you needed to do the entire compound, you would just do this again for sodium, for hydrogen, for carbon, same exact process. The next chunk of this assignment is on empirical and molecular formulas. So I first wanted to start with some definitions. Empirical formula is the smallest whole number ratio. Remember, the whole number ratio is the subscripts. So this is going to be the reduced or simplified version of the formula. The molecular formula actually tells you how many of each atom you have in a molecule. Okay, it does not have to be reduced or simplified. Sometimes they are the same, but they do not have to be. So ethane, our example here, looks like this. So to find the molecular formula, all you have to do is count the atoms. So we have 6 hydrogens here and 2 carbons. So that's how I get C2H6. To find the empirical formula, you simplify that. Okay? So when you simplify C2H6, which just means reducing the subscripts, you get CH3. So the empirical formula for ethane is CH3. Now, I just want to be clear, you are never going to be responsible for drawing out the structure like I did here, okay? That is an organic chemistry concept that is beyond the scope of this class. But you will notice on the summer assignment, there are some pictures of structures that you then have to find molecular empirical just by counting the atoms and then reducing it. Okay, so that's okay for going from the picture to the formula, but you will not have to figure out how to draw the structure. So here are some steps for writing empirical formulas, okay? This is going to come from percent composition. So you'll either get percentages or grams. I'm going to show you how to walk through these steps with an example. So here's the example that I'm going to do. You might notice this is from the first page of lesson 2 in the summer assignment. I thought this one was particularly tricky, so I wanted to make sure I did it out for you. So the first step here is if percentages are given, write them as mass in grams. What that is called is assuming a 100-gram sample, and we do that a lot in chemistry. We assume a 100-gram sample. So if we know that there's a compound that is 43% phosphorus and 56% oxygen, if we assume a 100-gram sample, we can just change these percentages to grams. So now we know it's 43.63 grams phosphorus and 56.36 grams oxygen. And that just makes it easier because our next thing we're going to do is convert grams to moles of each element. To do that, we're going to do a two-step or two-factor conversion stoichiometry problem, which again, we did last week. So if you are confused about how I'm getting this, please look at the notes from last week. So both of these are going to be two factors because you're going from grams to moles of one substance. So here you have 1 and then 31 because that's the molar mass of phosphorus off of the periodic table. So that gives us 1.41 moles of phosphorus. And then we do the same thing for oxygen. So that gives us 3.52 moles, moles of oxygen. So that's step number 2. You do that for however many elements you have. So if you had 3 elements, you would do it 3 times. Step number 3 says to write the mole ratio. I usually like to write these as fractions, okay? So all I'm going to do is take these two numbers and make them a fraction. So I'm going to put 1.41 moles of phosphorus over 3.52 moles of oxygen, okay? You can write the ratio like the other way of writing ratios, but it just makes sense to do it as a fraction. So the next thing you're going to do, number 4, if the mole ratio is not whole numbers, divide by the smaller number. So we'll get to the point where we say it's close enough to a whole number. It has to be 0.0 or 0.9 to be close enough to a whole number. Now this is 0.4 and 0.5, so those are definitely not close enough to a whole number. So what we're going to do is divide both of them by the smaller number. So 1.41 is the smaller number. We divide both of them, and we get 1 mole phosphorus and 2.5 moles oxygen. Those are still not close enough to a whole number. I mean, obviously the 1 is, but 2.5 is not. So that brings us to step number 5. Step number 5, if the mole ratio is still not whole numbers, multiply by the smallest number that would make them whole numbers. This is usually going to be a 2 or a 3. Sometimes you'll have a 5, but usually a 2 or a 3. So here, if we multiply both of these numbers by 2, we get 2 moles phosphorus and 5 moles oxygen. Okay, so I'm going to go with 2. It says go with the smallest number. That's the one I'm picking. And then the last step is to use the mole ratio to determine the subscripts. So all that means is that this number is now the subscript for phosphorus, and this number is now the subscript for oxygen. So when I write my formula, I get P2, it's a terrible 2, P2O5. So the next one is going the other way. If you are given the empirical formula, how would you get the molecular formula? Well, you have to be given two things. You're going to be given the empirical formula and the molar mass of the whole compound, also sometimes called the molecular mass because it's the molar mass of a molecule. So here the empirical formula for ethylene is CH2. Find the molecular formula if the molar mass is 28.1. So the first thing I'm going to do is find our N. So our N, if you look up here, is the molar mass of the whole compound. This will be given to you in the problem. And then the molar mass of the empirical formula you should calculate. So here, our 28.1 is our molar mass of the whole compound. The molar mass of the empirical formula, we just find the same way we'd find the molar mass of anything. We go CH2, look up the decimal numbers on the periodic table, and we would get 14. When we do that division, our N becomes 2, or at least very, very close to 2. So then all we have to do is plug that N in here. So we take the empirical formula and multiply it by N. So we take our empirical formula multiplied by N, which is 2 in this case. So all that means is that you distribute the 2 on the subscripts. So we're going to have C2H4. And that is ethylene. So the last example I'm going to do on this video is putting both of those things together. So in this question, you are given percent composition, and you're also given the molecular mass or the molar mass of the molecule. So they want you to find the molecular formula. To do that, you're going to have to do the percent composition to find the empirical formula, and then the business we just did with the N to find the molecular formula. So we have carbon, hydrogen, and oxygen. So we're going to do our 2-factor problems to get our moles of each one of those elements. And then for hydrogen, you do the same thing. For oxygen, we're not given a percentage, so you have to figure out what it is. Remember, you're going to want these add up to 100%. So you would take 100 and then subtract 40 and then subtract 6.71. Okay, when you do that, you get 53.29 grams of oxygen. So you use that number to get your moles of oxygen. So there's our step number 2 under those empirical formula steps. Step number 3 is to write this mole ratio, and so it looks kind of funny because we're going to put a fraction with 3 numbers, but it's fine, it's just a ratio. And these are not close enough to whole numbers. There's no 0.9 or 0.0 here. So we're going to divide by the smallest number, which is 3.33. And it shows up twice, but that's okay. So then that gives us our new ratio of 1 mole carbon, 2 moles hydrogen, and 1 mole oxygen. Now these numbers are close enough to whole numbers. They are whole numbers. So we do not have to do that step number 5 for this problem. Sometimes you'll do step number 5, sometimes you won't. We can just go right ahead and write this empirical formula. So our empirical formula here is going to be CH2O. But that's not what the question was asking. The question is asking for the molecular formula. So now we're gonna take our molecular mass and divide by the molar mass of CH2O. Okay, so you find the molar mass of that, which is 30. When you do that division, you get 6. So then our very last step is to take our empirical formula and multiply by 6. So that gives us C6H12O6. And you might recognize that, especially if you've taken AP Bio before, because that is glucose.